dy over dx by implicit differentiation. Implicit differentiation because we cannot isolate y here. So we take the derivatives of both sides with respect to x. And I'm going to denote this dy over dx as y prime. So take the derivative with respect to x and same thing here. And this looks like tangent of some function of x, and we know that tangent of u derivative is secant square u times u prime from the chain rule. And when we have a fraction, we must use the quotient rule, which is this. Now in the left side, tangent u, so that is secant square x minus y times derivative of x minus y. Okay, that's u prime. So derivative of x is 1 minus y. Derivative of y is what we are looking for. That's the y prime. Okay, this is derivative of y with respect to x. So that is left hand side is equal to, in the right we need to use the quotient rule. So on the bottom, always bottom is square. Now on the top, derivative of top. Derivative of y is just derivative of y prime. That's what we are trying to find. U prime v means 1 plus x squared minus derivative of bottom. That's 0 plus 2x, just 2x times the top, which is y. Okay, we are done with the calculus, but the algebra is kind of not easy here. Now we need to isolate y prime, which is here. We can distribute this, but we got a fraction here. We can separate into 2, or how about if we say everything over 1 and cross multiply. This way we can get rid of the fraction. So this one goes here, so we have secant square x minus y times 1 minus y prime. I'm going to write that after writing this, times 1 plus x square and 1 minus y prime. Our goal is to isolate y prime, which is here. So I wrote this one first, this one, and then it does not matter which one you write first. But the goal here is to separate y prime. We cannot live inside parentheses like this. Equals, here just y prime 1 plus x squared. We don't have to distribute. We can if we like, but that's not necessary, 2xy. Because the goal here is to isolate y prime, and I prime is kind of good in this case. I meant y prime. So in the left, y prime is the issue, so whole thing we can distribute. So this times 1 is just that. Secant square x minus y, 1 plus x squared quantity square, minus the whole thing times y prime. Secant square x minus y, 1 plus x squared y prime. Okay, equals y prime 1 plus x squared minus 2xy. Now we want to collect the terms containing y prime in one side and factor y prime, then isolate. So here is y prime and here is y prime. So this is negative. So let's move this to the right side, means we need to add. We could have moved this to the left side as well, but this negative sign, when we move, that means we need to add. That's better. Then that forces us to move this to the other side. Only y prime terms in one side. So we already have secant square x minus y times 1 plus x squared quantity square in the left, add 2xy equals, after we move means we need to add. From these two terms we can factor y prime out. That's what we are trying to do. That leaves here 1 plus x squared. Okay, And when we move this, then this negative means we are adding plus everything secant square x minus y times 1 plus x square square. So y prime times the junk equals this. Then y prime is just whatever we have in the left hand side divided by this. So y prime is secant square x minus y 1 plus x square quantity square plus 2xy all over this quantity in the inside the bracket, which is 1 plus x square, parenthesis not needed because there is nothing to distribute, plus secant square x minus y times 1 plus x square square. And do not try to simplify. Okay, it does not look good, but this is what we are given. So dy over dx, I mean this is in shorthand notation for dy over dx, is this big expression, final.